Today we're going to take a look at Chapter 2, Section 3, Analyzing Graphs of Functions. Turn quickly to page 187. Have your graphing calculator ready for today. We are going to do a couple things with it as we're going through the lecture. And once you have those things gathered and your notes open, we'll get this one started. All right, so the graph of a function is a collection of all ordered pairs such that x is in the domain and y is in the range resulting from f of x. So we've been talking about domains and ranges. Your domains, remember, are the x values. The range comes from your y values. Remember that f of x is y. Okay, so your function value when you plug x in does give you your y values. Okay, so stated here, it's just a repeat of what we were just talking about on the previous slide. Domain comes from the x, range comes from the y. So take a look with me on page 187. If you're looking at the bottom there, they've given us a picture. So the graph of the function is provided to us, and they've given us three things to identify or answer. The first one, part A, asks us to find the domain of f. So domain, remember, is your x value. So as you're looking from left to right on this curve, what possible x values are there? Well, even though it's kind of narrowing, this parabola, this curve, potentially does not have a bound on the left-hand side. So truly, our x values can come in from negative infinity. But notice at the x value of -3, there's an open circle or an open dot on our curve. So that's telling us that the x value -3 actually is not part of our graph. Okay, and as you look through the rest of the curve, there are no breaks, there are no other x values that seem to be eliminated. So if we were to state what our domain is for this curve, we would simply sum that up as your x's can come in from negative infinity, but they are going to stop when they get to -3. And then they will continue on the other side of -3 to positive infinity. Okay, so that's how we would state our domain for this one. Now letter B asks us for function values f of 0 and f of 3. So if we're going to calculate those, if they give you the function, you can plug 0 in for x and solve. But this time we don't have the function provided, we just have the graph of it. So find the f of 0 point. Okay, so if you plug the 0 in, it's looking like we end up with a value of 3. Okay, can you guys all see the point 0, 3 on the graph? So when the x value is 0, the y value is 3. Same thing for f of 3. Find where the x value is 3, and the f of x is -3, or the y value, not -3, -6. So f of 3 is -6 to go along with that input of 3. The range of f. Remember, range refers to all of the y values or the f of x values that we have in our curve. It's looking like this one goes down forever, but it does have a maximum point or a topmost point at 3. So our range would go down as far as it wants, but it's going to stop on the point where y is equal to 3. Now on page 188, all right, if you turn there for me, if you're looking at determining whether or not a graph represents a function, if you guys remember back to Algebra 1 and Algebra 2, we had something called the vertical line test. If you have a graph of a function and a random vertical line drawn anywhere through it passes the curve one place, okay, so it's going to have one intersection point on the curve and no more than one, it passes the vertical line test and therefore is a function. But take a look with me on page 188 at the first picture they give you. Okay, so example number 2, letter A there. Notice how that red vertical line passes through that sideways parabola twice. That fails the vertical line test. All right, so that first picture in the middle of page 188 is not representing a function. If you look in the middle, letter B's curve, that one will. So letter B would represent a function, as would letter C. Okay, any vertical line through C, again, is going to pass that vertical line test. So let's go down to the bottom of the page, check point number 2 at the bottom. you're given this kind of down-facing parabola. Well, again, any vertical line passing through that curve, it's going to have one spot where it intersects. So this one is also a function. All right, so that's just a visual representation of how to figure out whether or not you're looking at a function. If it passes the vertical line test, it is. Let's go on to the top of page 189 now. We're going to deal with zeros of a function. We have been talking about this in a sense already. We've been taking a look at things that make quadratics or make functions or equations equal to 0. So in a sense, we've already been playing around with this kind of thing. So on letter A, the function we're given is 2x squared plus 13x minus 24. If we're going to figure out zeros for this function, we are in fact looking at a quadratic. So best bet on this one is to see whether or not you can factor it. So our 2x squared will split into 2x and an x. Now I'm looking for numbers for the negative 24 that are going to combine with that 2 out front in order to give me a 13 in the middle. This might take a little bit of playing, but the 8 and the negative 3 will give us what we're looking for. The zeros then are going to be the solutions of these individual factors. So the first factor, and you guys already know this from previous sections, that's going to have a 3 halves. The second factor would have a 0 at negative 8. Take a look at letter B. G of t is equal to the square root of t minus 25. All right, so let's set this one equal to 0 and solve. It is a radical expression in our equation, and to get rid of that square root, you guys know that we're going to square both sides. Well, the square of 0 is still 0. The square of the right-hand side is going to leave us a t minus 25. So if you add 25 to both sides, 25 equals t will be our 1, 0 for that function. Letter C at the bottom, we have a rational function. H of x is equal to x squared minus 2 over x minus 1. Now recall that zeros, okay, so having a 0 value for a function comes from numerators, because in our discussions we've talked about what happens when you have a 0 in the denominator. Zeros in the bottom or the denominator of a fraction are undefined. So I really am not focused on the x minus 1 part of this function at all. I am focused at the top, x squared minus 2. Where do I have zeros for that? Because that numerator of 0 would make my entire function equal to 0. All right, so this is one maybe off to the side. We would write out like this and solve. So adding 2 to both sides gives me 2 equals x squared, and now I can extract square roots. And I'm going to have plus or minus root 2 as my zeros. Okay, x will equal plus or minus 2. Increasing and decreasing functions is another topic for this section. A function is increasing if the value from x1 to x2 goes up, and the value of y1 to y2 goes up as well. A function is going to decrease if the value from x1 to x2 goes up, but now the values of the y's are going to go down. That's kind of common sense. Okay, and you're going to be able to tell that if you look graphically at it, if you have a portion of your graph that's rising versus falling. Okay, so this is going to go hand in hand with slopes in a sense. We also have another situation to consider. A function might be constant. Constant functions are if the x value goes up, the y value stays the same. It's going to look like a flat line. So you might have a function that does this, so it increases for a while, and then it goes like this. And then from there, maybe it increases some more. But for this portion of the function, we would say that it was constant. Okay? Checkpoint number 4, let's play with this a little bit. It says graph the function f of x equals x to the third plus 3x squared minus 1. Then describe the increasing or decreasing behavior. Go ahead and enter this into your calculator. Try to get it transferred off to the graph in your notes here, or make yourself a sketch. You can also do a table that has some exact values of it. Either hit your table button on your calculator and get some integer points, or do an XY table and find them for yourself. And you guys know me, I'm old, and that's exactly what I did. So I know that if I put a 0 in, I get a -1 out. When I put a -2 in, I got a 3 out. And when I put a 1 in, I also got a 3 out. So my curve, and if you look on your calculator, you see that it's going to have some up and down to it. So 0, -1 was a point, so I'm going to graph that. -2, 3 was a point. And also 1, 3 was a point. All right, so it came from down here, got there, scooped down, and then went up again. Okay, we're going to be talking more about this shaped curve in section 4 when we visit our parent functions, but for right now this will do. Okay, this is enough information for what we need. So let's take a look now that we have our sketch and describe that increasing, decreasing behavior. All right, so for a portion of it, okay, so coming in from the left, you can see that it's going to increase until it gets to an x value of -2. So I'm first going to say that from -infinity to that -2, I have an increase to my function. At that point, till I hit an x value of 0, it falls or decreases. And then from 0 on, it's going to increase again. Okay, describing that behavior. Curves like that have increase then decrease or vice versa are going to have what's called relative minimum and relative maximums in them. A minimum, of course, is going to be a low point, and a maximum is going to be a high point. Okay, so you'll be able to tell when you're looking at a graph, whether it be on your calculator or sketched on your paper, whether or not these minimums and maximums occur. If you're not given a picture of the graph, you're going to need to graph the function on a graphing calculator so that you can use your zoom and trace figures to figure out those minimums and maximums. Okay, you can also hit your table button and see those values and be able to tell where your minimums and maximums are from that. Let's take a look at checkpoint number 5 on 191 that deals with this. All right, so we're given this function, -4x squared minus 7x plus 3. And I want you all to load it into your graphing calculator and hit the graph button. So go into your y equals. That's where you're going to enter in your function. I think you guys all remember this from algebra class. And then once you have the -4x squared minus 7x plus 3 entered, go to the far side and hit the button graph. And the curve will show up for you. Now it's going to roughly do this. Okay, now I want you to use your trace feature and your arrow keys to try to get as close to this value as you can. Now obviously with the shape of this curve, we're looking for a maximum. All right, if the curve would be shaped like this, then we'd have a minimum to it and no maximum. So use your trace key. Now when I traced, the closest I could get to the maximum ended up being something to this effect. But when I hit the table button, then I saw the value -1, 6 with integers in it. And that point does test as a solution to this function. So even though my trace key would only get me to this, I did use my table button to find that actual integer value. Okay? Average rate of change is another thing that we're going to deal with in our function section here. Now if you look real close at this average rate of change setup or formula that they give you, remembering that f of x is the same as y, do you see that if I made that switch back to y values, this is simply looking at a slope formula. So average rate of change is another way to describe the slope of a graph. And you guys have done plenty of that. Let's see that with this checkpoint number 6 on page 192. It asks us to find the average rate of change of f of x when x1 is -3 and also an x value of -2. All right, so if we're looking for that average rate of change, and we know we're hunting for something like the slope to tell us that, I have two x values given to me, and I have a function. So if one at a time I plug those x values into my f of x, I'm going to get the y that goes along with them. All right, so let's start out with f of negative 3. We're going to get a negative 3 squared plus 2 times negative 3, so 9 minus 6, or 3. So one ordered pair is negative 3, 3. Let's do that with our second x value. I want to find f of negative 2. So negative 2 squared plus 2 times negative 2. That gives me a 4 minus a 4, or 0. So there's a second ordered pair to work with. I plugged in a negative 2 and got a 0 out. So if these are our values, x1, y1, and x2, y2, I can figure out my average rate of change by simply determining my slope. So 0 minus 3 are my y values, and negative 2 minus a minus 3 are my x values. So negative 3 for the top, and a negative 2 minus a minus 3 is 1. So my rate of change is going to be negative 3 to 1, or negative 3. There's another function given to us in checkpoint number 7 on page 192. We're going to take a look at part B here. It says there's an average speed function, s of t is equal to 20t to the 3/2 power. Just because of that 3/2 power in this one, I wanted to play with this one and make you guys take a look at those. It says find the average speed of a car from t1 is 1 second to t2 being 4 seconds. All right, so again, we've been given two t values. Notice in our function, they are in the kind of that x position that we're used to. And of course, if you calculate s of t, you're going to get your output or your y value. So let's go ahead and find ordered pairs. So first of all, I'm going to do s of 1. So 20 times 1 to the 3/2 power. Now 1 to any power is still going to be 1. So this one is pretty simple. 20 times 1 is 20. So my first ordered pair is 1 comma 20. Okay, let's do that with t sub 2. We're going to find s of 4 now. Okay, our second t value is a 4. So now we're going to do 20 times 4 to the 3/2 power. Okay, let's take that 4 to the 3/2 power off to the side here. Now you guys remember that when you have these rational exponents, the denominator of that exponent is the root that you're working with. So since the denominator is a 2, this is simply a square root of 4 to the 3rd. Okay, now 4 to the 3rd is equal to 4 times 4 times 4, or 64, and the square root of 64 is 8. So let's bring that back over. We end up simplifying to simply a 20 times 8, or 160. So my second ordered pair is a 4 and a 160. So let's now use our rate of change formula. We have 160 minus 20 over 4 minus 1. Okay, that's going to be a 140 over 3. So reducing that, we're going to get roughly 46.7 feet per second. All right, that's all I have for you. Your assignment pages are 194 to 196 this time. Some of this stuff is familiar, some of it's not. So make sure that you're doing a pretty good sampling of the practice problems so that if you're having trouble with anything, we can come back together as a group and discuss that. All right, that's all.